Derps and derpettes. All right, so we're back. We have 4 things really to do. We're trying to build 2 modules today: an envelope generator and an amplifier, a transistor amplifier. So let me go get the shit and we'll start. Toolbox. All right, so this is what we built yesterday from scratch. This was a copper board yesterday, and we built this onto it. It's pretty cool. We also did this one. It's drilled, but it's not. We need to solder it. One thing to note about doing this yourself is that it's very hard to get things aligned top to bottom. I mean, even if you're off by 1/4 of a millimeter, it makes it really annoying to solder to. So what I did to remedy that is I actually went in and did my custom footprints in KiCad so that I could make everything bigger so that it's more likely that I don't destroy a pad or get off center. Okay, so we're going to be finishing this, then we're going to do this, then we're going to make 2 front panels. Today's going to be a long day, so we're going to just settle in. I need to get parts, and so I need, let's see, what do I need? Let me get my ball. Okay, so here's my bill of materials, and it looks like we need Do I have my pen? I need my pen, bruh. How can I do anything without my pen? Okay, so it looks like we need these potentiometers because all three of these are going to be mounted on the panel. Then this switch, where did I put that switch? I can't believe I forgot already. Oh, I know where it is. Okay. So then we need to mount that switch to the front panel. So these are all front panel mounted. Okay. And then we have 4 connectors. So these are all going to be so let me open up my schematic here. Okay, so what is J1? I always forget. So this is going to be a 1/4 inch. This is a 1/4 inch. This is a 1/4 inch. But now J2. Where's J2? Oh, J2 is power. We already did that. Okay, cool. I'm going to need to cut all these pricklies off. It's getting cumbersome. But damn, do the traces look good on here. The traces look really good, guys. Okay. Am I clipping? Nope, I'm not clipping. Turn it up slightly. Okay, so let me just grab the potentiometers and the we need the wire and we need wire strippers. Wire strippers, and then the potentiometers and the okay. We got a little pot, and we got some jacks. Now we don't need this bomb anymore, I think. Actually, we probably do need it. Son of a gun. I'm so sick of that. Much better. All right. Okay. We're finally ready. Okay, so these 1 millis are here. Gosh, this smells awful. Okay, wait, do I need more than that? And then I need a 100K. I feel like you run out of these kits, I feel like, I don't know why, but the potentiometers are like the thing that, I don't know, they bother me because they're so, actually, I wonder if the pitch is right. That's crazy. The pitch is right. That's so funny. Anyways, we're not mounting them to here. We're only using wire to mount them. But I think that's funny that we, that I guessed it right. Okay, so, so for these, we're only using 2 of them. And we want the wiper to show, hold on, let me check my frame. That's my frame. Not bad. Okay, so basically what we're looking at here is there's a wiper in here, and the amount of resistance will be most on the first 2 when it's all the way clockwise. Okay, so yes, we want to use the first 2 for all of these. So let me just cut that. So how do we want to do this? Because what are the ends connected to? One goes to the diode. Okay, they both go to the diode. So I don't know what color I should make them. I guess we'll just use white and yellow, because those are the things I've used the least of. Okay, so let's do it. So we need, and then actually, the 100K is this sustain value down here, and this needs a, I'll say red, white, and black. So we need 2 yellows. So we'll just start with that. 2 yellows, 3 white. Okay, so then we need the black wire for the ground. And then what are we going to use for pin 1 of that? I really wish I had a silk screen. It would make assembly so much easier. Okay. So I gotta cut that long. Let's use red. But red really isn't the right thing. So I guess we'll use white. Okay, so now we can get on with it. Okay, so we wanted pin 1, so wait, we gotta strip all these. Okay, so let's do the millies first. Milli, vanilla. Okay, how do I want to? I guess I'll get it on here like that. Okay, so now we wanted pin 1 to be white. Huh. I wonder which way I want to do this. I guess I'll put it in the thing that makes the most sense. Alright, let me arrange it first, because I'm being a dip. Okay, white. Yellow. Maybe I should put them through the back. I don't know. Okay, let's just do this. Cool. 1 down, 2 to go. White. Yellow. Woo, woo, woo. That song is so catchy, bruh. I think we probably just soldered the backs. One to go. All right, so we need to actually look at this. So pin 3, where is it on the PCB? That's the question. Did it say no package updates available? Okay, so this is 1. RV1, yeah. Okay, so pin 3, so it's gonna be like this, where pin 3 is there. Okay. Okay, that's 1. Now pin 2 is yellow. Oh, I did this fucking wrong. Damn it. Okay. Not a big deal. Maybe I should bend it first. That's way better. Okay. Oh, soldering to these is so much easier than soldering to these, which, speaking of, we need to do right now. And we need to make... Oh, well, I guess we could do the switch. The switch is inside. I need a piss anyway, so take a second. Okay, so we have a switchy switch. Okay, so this switch is called a single pole double throw because no one knows. So I'm actually going to use. Oh well, I'll test the wire. Well, let's see. I need to know what colors to make the wires, but I also need to know the connectivity. So the switch is here. This thing can handle 5 amps. Okay. I know what the connectivity is. So that means that the output is the middle pin. So I don't know what to do. I'm just going to use yellow, white, and green. I don't think that's long enough. Okay. Bro, at some point you just have to work fast. Like, we need this done. I need this done, bruh. I thought I had a longer one of these. There we go. Okay. Oh, and this is a little bit tricky because while there are holes, I think there are holes. Okay, whatever. We're just gonna do it like this. So green is gonna be the output. Fuck, I didn't wait long enough. Okay, we need to go over it again, but... Okay, now I guess I'm gonna make pin 3 white. It would be much better if I could, Okay, now we're gonna turn it this way. And I'm just gonna try to feed some more solder to it without it falling. That's actually impossible. Lol. Fuck. There we go. Okay. Alright, this is good enough. Tug on it, they don't really come out. Okay. So now, part of the challenge here is... Okay, so pin 1... I mean, it doesn't actually matter which way it is, but pin 1 is yellow, I guess I've decided. Oh, no, white is. Wait. White is pin 1? Okay. So part of the problem here is that we use both sides for some of these, so we need to be able to solder onto both sides. So I'm actually gonna take a little bit more off of this thing. Okay, so now you can feed this in and bend it like Beckham. So we'll bend this side in and this side out, I guess. Then green. Green, it's only the back side that has any pad connected, so you can just put it in there, I guess. And then yellow. And yellow also has pads on both sides. Okay, so first we'll do this side, I guess. We got this flipped around. I like to use this side because it has a rubber thing on it. Actually, should we just put these all in? Okay, so this one... Wait, I think I put this in the wrong spot. I definitely put that in the wrong spot. Okay, yeah. The switch is over on this side. That's annoying. Okay. So let's put the 100K in here. And pin 3 is the ground. Alright, I'm going to take more off of these too. Okay. I think I did too much. But it's longer than 6 centimeters, so we should be okay. The white one is a little short. Whatever. I think it's going to be okay. One. Two. Three. Okay, I guess, yeah, we'll put them all in. So the switch, pin 1 of the switch is there. So yellow, wait, no. Bro, why do I... Dude, I did this one wrong. I'm such a dumbass. Okay, whatever. It doesn't really matter. It doesn't matter. But I am a dumbass. Fuck. There we go. There we go. And there we go. Come on, get in there, bastard. Okay, that's good enough. Okay. Now we need these guys, which are down here. Okay. Okay. So now we have most of the control done. I guess I'll solder these, and then we can do the rest of the control. All cones, baby. All cones. Yeah, there's plastic all over this thing. It's kind of annoying. We flip it, 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 we flip it. Wait, am I even in frame? Bro, I always do this. We need to... Camera eats first, bro. I hate that saying. I don't hate that saying. I just think it's silly. Okay. Good stuff. Okay, so we have sustain. We have... We'll need to label these. I guess we'll label them on the front panel because I forget which is which. Okay, so let's get these guys going. And here at least the colors make sense. We only need 3 of them, I think. We need 1, 2, 3. Okay. Soldering to this sucks. I'm actually going to wear glasses for this because it sputters and drips so much. Honestly, it's just like... It's just annoying as hell to solder to these things. You're my drug, my vice, then. Okay, so that's 1, and we need 3 of these. 2. Oh, no. I hate when this happens. Oh, actually, no, it's not what happened. It just got... Okay, and then we want white for signal, I guess. So we need 3 white. The problem with this part of assembly is it's so rote. It's just so, like, monotonous. Because the problem... we just want to be able to test. And actually, it's going to be a pain in the ass because I don't really know what to expect. Okay, I always forget this. The bubble is signal. You're my drug, my vice, yeah. Okay, that's fine. This is basically where I think 90% of my problems come from. Yeah, see, that is a cold solder joint. Okay, I guess I'm gonna go get a toothpick and some flux. I don't like the flux though. Okay, so we got some of this stuff. I've never used it before. I'm actually gonna wear a mask for this because this stuff looks like death. I think it did sort of help. Alright, so I guess we're using that stuff. Yeah, it does not look like a cold solder joint at all. Very good. Very, very good. That's sticky icky. Oh yeah. Oh baby. I don't know what it's made of, but that shit gas, bruh. That shit glass, duh. Mr. Fast, bruh. She's soda gas, bruh. My question is, how does it work? Like, why is it working so well? Okay, cool. So now we can mount these. Okay, good. Wait, is pin 1 ground or is pin 2 ground? Pin 2 is always ground. You're my drug, my vice, yeah. Okay, and the board is done. We just got to do this backside. And then we got to put in the op amps. Dude, who invented the op amp? The op amp is one of the sickest things ever. You use it for everything. Okay, should I get the op amps? Okay, so here's what we need to do to test this thing. I think I want to test it off batteries because I really don't want to short my power supply again. I mean, I think it works, but... I mean, I know the power supply works, but I don't know if there's a short in my... What I could do is I could just start to use this flux to resolder all of the... Alright, I guess I'm going to do that. Okay, I don't actually know if this is going to improve anything. But it should. But anyways, so what we're going to do, we're just going to go one by one. And I'm actually going to just... yeah, I think I'm just going to redo them all. Wow, look at how thin these traces are compared to the traces that I had before. Or that I have now. I like big traces and I cannot lie. I'm gonna... Okay. Alright, it seems pretty good. Okay, so now I'm gonna put this back. I'm gonna use this later probably, but I'm putting this back. But what we need to do now is get a breadboard, get my batteries. God, it's such a pain to power this thing. I should make another power supply. Okay, hold on. It's so true. Fear is the mind killer. If I can't at least use my oscillator and my power supply together, what am I? It's a broken thing. Okay, so we open up this program called Waveform. Oh my god. Windows search is so stupid. Why would I ever want that? Not the application. Prefer the application. Okay, so now we have oscilloscope open. Okay, then we have a 12 volts AC wall wart. And I need to go get the power supply. Yeah, probably not. Probably don't have the cables. Alright, but we're just gonna do a repeat test of yesterday to make sure it wasn't a fluke. Going step by step. Okay. Okay, so we have the meter. Hook that up to plus 12 volts and ground. God, this thing is finicky. Okay. Now, turn it on. Take the end of this, plug it in. 12 volt, 11.7. Not bad. Okay, now you need to do is take this off and connect it to here. And we're getting minus 13. And that's not great because I think the operating region of this thing is supposed to be, like, I don't know why it does that. But okay, fine. It shouldn't burn up our board. Okay, so we're going to unplug this. Then we need our connector cables, which I got to go find. But basically we're going to hook this up to the power supply, and then we're going to hook this up to our our nice new outputs. Okay. Okay. Oh, we don't need the meter anymore. We know it works. Ah! My baby is a tank, bruh. My baby is a tank. Okay. So, to start with, we're not going to use any control voltages. We are just going to hook things up simply. Gosh. Okay. So that means ground is the outermost. Okay. And then we just need ground plus 12 volts minus 12 volts. Okay, so now we should, if we click run, okay, we're not getting anything. Well, actually, we are getting something. It's kind of neat. Okay, I think that's just noise. Ground noise or what have you. I don't see any shorts here. See some kind of close calls. Huh, I wonder what that is. Boop, boop, boop. Let's see, let's make it, because we're expecting so let's make it 2 volts per division. Wow. What is that? Like, I'm afraid to put it in the... That is not good. How is that happening? Wait, hold on. Let me make it bigger for you guys. This is so strange. Okay, so wait, hold on. Let me turn off channel 2. Okay, so we have some sort of oscillation. But if I touch any of these pins, we get this signal that just keeps growing and growing. And before it was getting to 25 volts. I hope I didn't damage the anyway, I mean that's a huge oscillation. What is driving that? This thing is not plugged in. I'm wondering if this is what killed the... So I can't touch this thing or I'm going to fry it. This makes absolutely no sense. What could be causing that? The thing is, if I plug a speaker in there, let me go get a tiny little speaker. There's no way that we're going to be able to hear that. Like, I don't know why it's giving me such a high voltage reading. Like, that oscillation should be audible. Okay. So I think this one's broken. These wires, I think they're just broken. But I have ones with just leads on them. And I just want to see if I touch this. So we're still seeing like a 10 volt peak. Or wait, no, a 20 volt peak to peak. That should be loud. Okay, so I need to... So what do I need to do? I need to get this guy wedged in here. And this guy on here. Okay, let's try the thing. See, if I touch anywhere, huh? Like, I'm pretty afraid of that signal, because... Well, you know what? We have to do it. Okay. Okay. No sound. We have oscillation. We have AC coupling. Let's see, do we have frequency control? Oh, I thought I heard it. Okay, wait. Let me unplug this guy. Connect this to here. Okay, do we have frequency control? Alright, so things are working. I think the speaker is broken. We can maybe test that with this theory. Wait, what happened? Why do we have such a noisy signal? What was that? Should be making sound. It is making sound. It's a really low sound though. Alright, let's try square. Square busted. Square does seem to be busted somehow. What happens if we do this? Oh wait, is this just a duty cycle problem? See, that kind of noise is not good. I don't really know what causes it. So, okay, so when it goes high, I think it's actually doing its thing. But for some reason, I can't get the duty cycle to do the pulse width modulation. So maybe it is busted. Could be another bad joint. Well, we kind of want the square wave to work though, because that's what the envelope takes. So what does that mean? That means, actually, why aren't we getting a signal? Something is still really loose. Okay, go back to this. Oh, did I burn something up? Oh no, it's just power keeps coming out. It's total bogus. Okay, we need to fix this. This is so insane. So what is that noise? That's so bizarre. What is that? I just tapped it and it locked back in. This is what happened like a week ago when I was testing this thing. Watch, if I touch this thing, it'll make sound now. Is it? Can't tell. Yeah, it is. It's very quiet. Gosh, this is infuriating. Okay, we're unplugging the power supply. I need to look at the bottom of this thing. Okay, so what is it that we're doing right now? We're debugging the square wave. So can we get the square wave at all? Show up. Okay, for some reason it's... Oh wait, I think that... No, that's more pitch. This is the PWM. Okay, I wasn't actually modulating the PWM. I wasn't doing anything. So maybe we have a shot here. So let's see. Okay. There we go. I don't know why the trigger's kind of off, but okay, but that's good. That's good. That means that we should be able to test our new circuit. So now what we want to do... Jeez, this is such a mess. Okay, so now what we want to do is we're going to introduce this guy. I'm going to unplug the power supply. I'm always worried about shorting this baby. Okay, so we need another one of these strips. So we need another one of those strips for this power. All right, I'm gonna go look for that. Okay, we got something kind of jank here, but basically we got not the right colors, so. Okay, so now the I/O is going to be annoying. What we want is we want a really low frequency square wave. So let's just let's take this out of here. Where's the power supply? Okay. Cool. I love that it just works. So now we want to make this really low. Other way, other way. Okay, let's see. If I measure that. That's a delta of 12 milliseconds. That's huge. That's not good enough. Okay, what if we zoom out now? Ugh. Okay, what is this? I think we need a CV for this. $300 milliseconds? That might be short enough, or that might be long enough. Okay, so we need the you know what? I think I'm gonna build the front plates now, because integration testing is so. Oh, I forgot to get the op amps. I'll put the op amps in, and then we're gonna build the front plate. It's probably gonna be rainy today, so I don't know if this is gonna work. Okay, so we need to unplug the power supply and then cook up some designs. So we need to. All right, so I'm gonna make this oscillator with aluminum, and then we need to remember everything. Okay, so this is complicated because I haven't done this in a while, but Should be easy. Oh, we had one of those connectors right here. Whatever. All right, so what does this mean? All right, so to build the front panel, we just need a drill, but then we need the right size. So what I'm going to do is get a test piece of acrylic and find the right size for, let me show you what I have here. Okay. It's all right. So we can disconnect all of this. We can stop the scope. Stop the steal. Beep, 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 beep. Okay. So basically, oh yeah, the op amps. That's okay. We don't need them yet. God, there's too many control elements on here. I don't know how we're gonna do this. We're gonna need to find a bolt, a nut for that. Okay. So here's what I have. I have these things. They're standoff. They're M2, which is kind of small. And then I have some M2 nuts and washers. Nuts and washers. So, I have imperial bits, but I need to use an M2 standoff. What size should I use? But because the thing is, it needs to be bigger than the screw size, but it needs to be smaller. Than this. Alright, so we're just going to try something, I think. Okay, so we need that wood block, we need a clamp, and then I need to dry the table off. Oh, I forgot the clamp. Forgot the clamp. Okay, so we got our setup here. Now I'm gonna grab this, or I'm gonna grab a different one. Okay, what's next is that piece of acrylic. Okay. Okay, so I guess I guessed right, but you can see the problem here. What I think I'm going to do is I'm going to put this side here, and then I'm going to use, I think it was the 12 length. Okay, so here's what I think is going to happen. We have our hole, probably can't see it. Stick this bad boy through there. Okay, hold on, let me just turn off this stupid thing. What is the point of that? Okay, then we can do this. Ooh, that's actually perfect. There's no problem at all. Because the thing is the thickness of this. Alright, so we're good. Let's see, what drill size was that? I'm going to add that to the readme of the get thing. Okay. Code. Okay, so I'm going to write build notes. For the M2 standoffs I got, use 1/8 holes, 1/8, inch holes. And use the M3 by 12 screws into the acrylic, and there is no need to countersink. Okay, cool. So that's a good note, and it's in a place where I will actually remember it. So now we just need to get the correctly sized piece of acrylic, cut it. Dude, this worked out so well. And the thing is, this is sturdy, bruh. Cool. I like it a lot. I'm just trying to think what else we need on here. So let me get my old design. I can show you guys my old design. Okay. So here's the original design. And actually, should I use CAD for this, guys? Maybe I should CAD it out. It should be really easy to do. Yo, no more drawing, guys. Now I know CAD. I'm going to CAD out the front panel. Alright, so we need to clean up to do that. It's such a pain. Anyways, alright, I'm going to put this back. But yeah, so this is it. The problem is I have much more room here. So we need to design two things. We need to design... Oh, we actually need to measure the thickness of the acrylic. Let's see if I can do that just with a ruler, but I am not confident that that will be good. It's probably in Imperial. I think this is 2/5 of a centimeter. I'm gonna get calipers. Nah, what am I doing? That's a total waste. Okay, so we're not gonna need the soldering iron for quite a while. Or the fan, for that matter. We don't need the scope either. Okay. Oh, wait. Okay, now we're going to do something drastic. Drastico. Oh, sheesh. Okay. So now we can just go to normal. Alright, and we're going to CAD this out because... Should we use Fusion or free... Bro, I kind of want to use Fusion. Is that wrong of me? Guys, is that wrong of me? Okay, so... I'm building a modular synth module that has a front plate made of acrylic and uses standoffs to connect to a back plate using backplate PCB. I want to use Fusion 360 to place the front panel elements and the standoffs, but I don't know how to put, I don't know how, but just say that. I just want to read this. Delete. We don't care about that. Close. Okay, so let's think about this. So we need a sketch, and the sketch is going to be a rectangle. Is there a, oh yeah, R, nice. Okay, and this is 10 by 20. This is going to be 200 by 100. Okay, this is the front panel. Now, we need to make, can I just make an annotation line? There was a way, oh yeah, hold on. Construction. Okay. Place first point. But I want to measure. How do I measure again? Inspect. It's I, right? So I want to take this point to this point. All right, so we actually want to change the constraint there. Here and here. Sketch is over constrained. Yeah, but I want to be the guy that says that it's not. What? I want to... That more info thing is not helpful. Wait, what is this? This error sucks, dude. Okay, let me read this. Draw the outline, add holes, determine standoff locations, add standoff holes, consider threaded inserts. We don't need to thread it. 3D modeling. Extrude the front plate. We're going to do that. Model the standoffs. I want to model the standoffs. This is more of a side quest, but it's also like I just want to be good at CAD. So I feel like it's worth it to like just get a few CAD projects under my belt. Okay, I want to make I'm in sketch mode, and I made a 200 by 100 millimeter rectangle. I want to add construction lines 2 centimeters from the top and bottom going across horizontally. I can draw the lines, but when I go to try to add the vertical constraint, I get over constrained error. Maybe I could just figure it out. Snap, slice, points, dimensions, constraints. What is this? Perpendicular oh, hey, it has a vertical constraint. We want to delete that. And we want to delete this vertical constraint. Delete. Okay, now I think I should be able to do it. So now if I do this and this. But how do I set the distance? I hate that. But, okay, wait. $150. Oh, this is just markers. But how do I change? What is the distance between these 2 points? Oh, it's 20. I got lucky. But how are you supposed to actually do it? That's my question. Okay, then I want a new line. Wait, oh shit. I didn't mean to do that. We need a line, but we need this thing. Because this actually has no bearing on anything. But then if I inspect this, I should get 20. Right, but I want to... Okay, let's see what it said. Oh yeah, I forgot about that. See, this is something that's a little different than... What are the movement keyboard short... Pan keyboard shortcut. Bro, I'm trying to get good at this. Middle mouse button. There's gotta be, I feel like there's got to be, there's got to be a hand zoom and orbit shortcuts. Is there not a setting built for trackpad? Oh, is that true? No, wait. Whatever. I don't give a shit. We just want to get this done. So this to this. Okay? And we want to set that to 25. Okay, nice. Dude, dimensions are so sick. I love it. Okay. Yeah, you got to spam D. Spam that D, B. Okay. So cool. Now we have that part of the front panel done. Now we want to place the front panel elements And I should have this thing in front of me. Okay, so let's make a rectangular grid of circles. So we're gonna make a circle. I don't know where it's gonna go, but it's gonna go. And then how do we make that Dude, I wish they had a command palette. Oh, but what he did actually is he went to solid, and I think I forget how we did it, but it was in here, and it was pattern, rectangular pattern. It's this thing. I wonder if I can do it in sketch mode. I mean, at some point we got to learn how to do this thing. So we're in sketch. We want to create rectangular pattern on this thing. Okay, so distance. This should be 100 millimeters. No. Hold on, we need to figure it out because. So the holes need to be how big? That's the question. Oh, actually, the holes aren't uniform, so maybe we need to do it. Well, okay, maybe we'll make the rectangular pattern, and then we'll make the pulse width smaller. But the hole needs to be big enough to. So let me get a potentiometer. How much can you guys see? It doesn't matter. I'm just going to drill until I find the size. Oh, oops. That's not what I wanted. I wonder, did I countersink for the knobs? I'm not gonna. I mean, that's stuck on there. That's pretty good. Okay, I'm just going to redetermine it. Okay. Okay, took long enough, but we determined that you need to mount pots to the acrylic. Drill 9 32nd inch holes. Okay. Very good. Then now we need to determine for a soft one of these guys. Okay, we need all right, so we determined that. The answer is 3/8. Okay. Oop. For 1/4-inch jack sockets, use 3/8 holes. Cool. So that tells us something. Oh, what? Did I disconnect? I don't know. All right. So we have freaking. I wonder if I can I put in. What if I put in. Dude, that is actually ridiculous. I cannot change the unit. That is totally crazy. Oh, wait. No, you can't. Okay. Thank God. That would be totally crazy. All right. Okay, so we need 1, and then this is going to be 3/8 inch. I'm gonna assume that's right. Okay, then we have 1 over here, and this is 3/8 inch. Wait, what? Okay, I guess when it's red, you can't do it. Dude, why? Okay, hold on. How to put inches in Fusion 360? Dude, this software sucks. Why can't it just do the conversion for me? Dude, that is actually cringe. How do you do it? Wait, I did that. What? Oh, wait, why did that work? Okay, let's try this. 3/8. Okay, but I can't do... Dude, the parser on... And this is so bad. How is that allowed? Dude, that is fucking insane. Can I copy and paste it? Dude, what is it talking about? Oh, there we go. And then we can add the constraints in later. Boy, is it taking a while. Dude, delete. Go away. What the fuck is that thing? Okay, alright. I'm not triggered, you're triggered. I think I have to do... Wait, what the fuck is it doing? Wait, what? Okay. But yeah, but what are we actually doing here? See, this is so annoying because it's like partly I'm just using the tools and partly I'm just okay. All right, so here's the deal. So we have so I think we want to divide this by 3, right? Because we want. Can I impose an equality constraint? Oh, there we go. What is that called? Okay, so if I do D to that, whatever that is, and then D from here to here. What? But we want it to be okay, whatever. And then okay. And then D from here to there. Create a driven dimension? I don't know what that means. Right, but what we actually want to do is we're going to take this one, and this one, and we want to say that they're equal. How do I take these dimensions and say that they're equal? Okay, wait. Are these considered constraints? Or what if I say? Oh wait, can I move this thing? How do I move it down? Holy hell. How does it know whether or not it's horizontal or vertical? How do I know if it's vertical or horizontal? I have no idea. Okay. Here's what we want. So we have 100 millimeters. Then we have a dot here and a dot here. And then we want this length, and this length to be equal. So we need that the distance from here to here to be 33. So wait, can I do 1/3 times 100? Okay. And then how do I say that they're okay, I guess I'm just going to do this. Okay, so then we have the other side, which is we have 160 millimeters, and we want to place 3 things, so we have 4, so it's 40 from the top. Okay, so then we want a D here, and a D here, and we want to say that this is 40. I just don't like this thing. Maybe I should go get my mouse. I'm not good at it yet. Okay. Okay, and now we want to apply the same constraints. So let's just do this the slow way. Okay, now I just want to measure, I just want to inspect this distance to this distance. Perfect. Okay, so now this one, we can do this to here, and this is also going to be 100/3. And then the distance here is going to be 40. Okay, so we're all good there. Now I want to copy and paste this thing. I want to move it down 40. And then I just want to change this thing to be, what did we say? We said 1/8. So this is a smaller hole. That looks too small. Is that right? No, 932. That seems about right. Okay. Okay, now this one you put here 100/3. Seems like they're a little close together. Maybe we should make it asymmetric. Maybe we should make this more like 25. Can I change multiple constraints at once? I don't like that. The constraint system here confuses me. Okay, but what if I just try to change all of these at once? I want to change them all. Can I change multiple dimensions at once? Okay, well, it's so annoying. I don't actually care. So what if they're a little close together? Okay, cool. So I think we did it, right? We just want to. I just want to add this thing, which is also 100/3. Okay, cool. So we have the front panel sort of done. Why does this have 2 lines in it? Oh, I don't know. Can't I just save it locally? This is called the synth. Okay, then in here, this is called the VCO front. Okay, so now we should be able to extrude this, right? So we finish the sketch, then we extrude it. And how thick is it's 2/5 of a centimeter. Distance, so it's 2/5 centimeter. Actually, I should be able to just do that. 2/5 cm. Dude, the resolving on this thing is so shit. I don't know why you have to multiply by the unit like that. It's like total garbage. Okay, but that is what it is. And then can I... Let's see, this plastic thing? Can I change the material? Whoa. What is it doing? Look at this. Dude, Fusion 360 is not that. This material name. I can't change the material name? How to change material of my extrusion in 360. Bodies. Body 1. Configure physical material. Oh. Great. Thanks, guys. Plastic. ABS. Acrylic. Acrylic clear. I want this one. Give me this one. Open the material, sign the material. Drag and drop the desired onto the component body. Okay, cool. Cool. Nice. All right. I mean, this is kind of what it looks like. Okay, so now... Oh, wait. We forgot to do an important part of this. I should be able to... Hold on. If I change this sketch, will it... Huh. If I change this sketch... I wonder if it will work again. We need to... Okay. So now we need to draw another rectangle, and it needs to be a construction rectangle. And so this is going to be on the back plate. And on the back plate we have 70 by... Or no, wait. We have a 100 by 70 millimeter for the back plate. I don't see why we couldn't center it in the whole thing. So I have a rectangle, and I want to make another rectangle in the I want to make a construction rectangle that is centered in the first. Is that possible? Fuck you guys. Okay. So let's just do this. So it's going to be 100 by 70. Okay, then. Okay, so how do I do the constraints here? I have this thing, and then I have this thing. Okay, and whatever that is, I don't care. But then we want this to here to be the same. Over constrained sketch. Right, I get it. So, can I make this free somehow? Let's delete this dimension. What? Sketch dimension. Okay, fine. Okay, wait. Let me just read what it had to say. Start with your existing rectangle. Create the construction rectangle. Draw another rectangle. It doesn't have to be centered or accurately sized. Make sure to set this new rectangle as construction. Add midpoint lines. Draw 2 construction lines, one vertical and one horizontal, each passing through the midpoints. All right, let's try that. So I'm going to delete this. And then what did he say? He said midpoint. Midpoint. No. What? Okay, wait. Add midpoint lines. Draw 2 construction lines, one vertical and one horizontal. Okay, so these are construction lines. Oh, that is the midpoint. That's nice. Is that also the midpoint? Oh, shit. Can I just move it? There we go. Okay, then another L. Okay, this is the midpoint. Dude, I'm kind of getting the hang of this, bruh. So then we have this point. Okay. Use the coincident. Okay, wait. How do I do this? Oh, yeah, midpoint. All right, so what I'm going to do... God, I hate the zoom on this thing. It's impossible. Get me out. Okay, so this point here... I don't know. I guess that constraint was already applied. All right, so now how do I use coincident? Use the coincident constraint to place the midpoints of the construction rectangle sides onto the respective midpoint lines you just created. Can I just move it and see if it'll work? Move. How do I actually move it? Give me... Boy. Let me Google it. Center a rectangle in another rectangle.
Suppose that we need to shift the whole rectangle off to the side of the origin. Is there a way to change this after the fact? If we hover over the center point, 3 coincident constraints pop up. If we hover over the first constraint, you will find that one of the diagonal lines get highlighted.
I don't know what I'm doing, man. Okay, we need to get more advanced, but okay, if that's 100, then that means that there should be 60 total. So that means that there should be 30. So if I just do this, okay, cool. And then here and here, so we have 70, so this should be 15. Okay, so now it's centered. So now what do we need to do? We need to find a place for the standoffs. So we need to make a hole. We need to make 2 holes. And then, oh, and then I guess one problem is that we need to make holes. We can't just decide where the holes go. We need to actually look at the PCB and say, where do we have space? So it looks like yeah, we're kind of screwed because we have these stupid mounts there. This is kind of tough. Whew. Okay. Okay, so I gotta go take a piss. Damn. This is actually kind of tough. It's hard to visualize. So if we drop this from 30 to 20, okay. Is this going to work? Like, I don't know if I can just do that. Because what matters is... Okay, so... Alright, so I think I got it. We need to place the hole 5 millimeters in on both sides here. From the... So, whatever. I think that's what I did. Maybe that's 10 millimeters. Maybe that's a centimeter. Could be a centimeter. But whatever it is, it's in there. And that... Okay, so let me just try to do this. Okay, so this needs to be 1/8 times 1 inch. Wait, did that work? Did that work? Okay, so we found a hack, I guess. Okay, now we want to go D, D, and we actually have to measure it out. Yeah, so we're doing it. Okay, so we're doing it 1 centimeter in on both sides. So this is 10. This is perfect. Yeah. And then same with this. And this is also 10. Yeah, oh great. Such fucking garbage. Okay. Alright, but now... Yeah, if I change this, then we're good. Okay, did that work? Okay, now we want to draw another circle. And then this circle, we're going to put in the middle. So how do I use the midpoint constraint? That's what I want to do. Because I want to use the midpoint constraint. Alright, and then I guess I'm going to put this 15 millimeters inward. Before I said I was going to do 10, but I think we're going to... So I think we want to put it there. And then this needs to be 1/8 times in. Okay, then we go D, D, and it's 15. Perfect. I like the grid. I feel like the grid is pretty good. Okay, so let me just look up how to use midpoint constraint. Fusion 360. Is this auto? Okay, yeah.
I'm Chad. Welcome to Maker's Bench. This is another sketch constraint video, and this time we're going to talk about the midpoint constraint. Midpoint constraint is actually one that's new to me. You don't have that one in Inventor. That's my program I use. I make a living using that program. So with Fusion, there's a few things that are different. This is one of those things that are different. So I'm not entirely used to it, but I do I have figured it out, of course, and it is a pretty simple, straightforward constraint. So I'm just going to put 2 lines here. Now, midpoint of this point, I want this point to be on the midpoint of this line. I always want it to be on the midpoint, so I'll use a midpoint constraint. I click on the point, I click anywhere on the line, and it places the
Oh,
point.
fuck. Okay. So, let's try that. So click on the point, and then we click on this. What the fuck? Okay, wait. Actually, I'm curious. If I delete this, and then I do midpoint, and I tap on that little guy, I tap on this. See, but that's not what I want. That's not what I want at all. Okay. Okay, well, can we delete this body? Wait, can I update it from... How do I update it from this thing? What was it? It was, 2/5 of a centimeter. Okay. All right, this is, and it's still body 1, which is nice. And then, but these aren't holes. Why aren't these holes? Oh, because they're construction? Oh, I get it. Okay, so now we want to save, finish sketch, and then we want to take this sketch. Did it put them in there? No. So we need to take this sketch and extrude it. Two fists. Why is it that these are holes and this is not a hole? What is the difference? Damn it, dude. What is it? What is wrong with this thing? I feel like I'm just battling the program a little bit. I have some circles on my sketch that... Wait, can I just delete this? Nice. Okay, alright, we did it. So now we just gotta make this thing. Loiby, boiby. Loiby, loiby. Okay. Okay. So these two circles are the only thing that really matter with respect to this rectangle, because all the other things we can move around because they're just wires. But so as long as we have these clearances, then we should be able to make it work. All right. Okay, I think we're good then. Okay, so I have this kind of crummy piece of acrylic. It's not really sized right. I'm bad at cutting. It's a little short and it's a little long. You might be able to just use a Dremel or something random to shave it down. Maybe the grinder. I don't know if I'm allowed to use plastic on acrylic on a grinder. Probably not, because it probably fills the holes. All right, so now we just need a. Actually, I wonder, can I print the sketch out? That would be really nice, because then I could just paste it onto the front of this thing. Can I print a sketch? Okay. Find the drawing drop down. Um, sheet size. Is this too big for a normal piece of paper? No. Okay, then why are you using A4 size paper? Oh, okay, wait. Place base view. Of course, you can't move it after that. That's great. Oh my fucking god. Dude, I hate this. All I want to do is use my sketch. Give me escape, bro. Give me escape. I don't like this. Okay. I want to take this sketch and I want to print it out. And I just want it to be to scale. Look at. Oh, the SVG thing? That might be good. No, not insert SVG. Boss. I know this program is cool, but it's just a pain. Okay, wait. Okay. Dude, why is it spinning? Oh my god. Okay, hold on. Print, sketch, Fusion 360. It's not, it doesn't need to be this complicated. That's what I'm trying to say, though.
Okay, after you have finished or downloaded your file, make sure it's saved somewhere. So we're gonna save as. Can't save as because it's already saved on my workbench.
Dude, people just say the dumbest shit. Give me the
and
thing that I...
this, left click on it and go here to drawing, and from design it's going to take you to the drawing worksheet, well, drawing workspace. Now you can all choose oh shit, done. So to get the right view. Okay, so this is going to be
oh, okay, guys. It's just frozen, man. This is seriously the program that everyone... It's got so much cool shit, and then stability is just a... Kill! Die already. Just die. Oh my god. Fusion 360 is just fighting me, bro. Oi, good oi, bloy. Oh, okay, it has a 1-to-1 thing. That's good. Oh, wait, I don't care. Okay. Alright, we're getting the hang of it, guys. We want to go design, drawing, from design, create drawing, full assembly. Why is it at that resolution? Okay. Now I want to print it. Okay, cool. Letter. scale, please say none. Wait, hold on. What happened? No, we can't fit to paper. It's got to be to scale. All right, guys. This is actually pretty cool. Okay. Well, that was painless. Actually, I might take a break to go get lunch. But what would be really nice is if I could draw a dot. Because I want a dot in the center of all my circles so I know where to line up everything. Okay, I'm gonna make some lunch. But I'll be back. I think I'm gonna print out a nah, maybe not. I don't know. We'll see. Okay, so here's what's up. So we printed out this drawing. Can you see it? Barely. But now I can just tape this onto the front and drill where I need to. Pretty cool, right? So CAD actually has some applications. CAD is not bunk. Despite everything I've been saying. CAD is not bunk. Okay, stream is back. I'm back. We got the printout. Now we just gotta drill. I guess I'm gonna get a glove just to do it right. And then we gotta think about how I want to do this, because I guess I want to cut it out and then use tape. All right, I'll cut it out and then I'll use tape. Sounds good. The much harder thing is making sure there's alignment in the back plate, though, because if you drill off a little bit, then you're gonna have to introduce some warping, and you don't want to put that kind of tension on the board. You know, it shouldn't flex at all. I think I just kind of got lucky with the first one. Okay, and then I'm gonna get some tape. Or actually, you know what? I should get some tape. But I think I might drill it like this, where the paper's under it. I think that's a good idea. Okay. This is what happens. Speaking of, I need my glasses. Alright, so we need to print out the paper again. We need to tape it again. Jesus! Alright, we're going to do the aluminum. We're going to do the aluminum. We're going to see what happens. Why won't the print work? Print. Print. Holy sh... Dude, this software freaking sucks. What is wrong with it? Why won't it print? I literally just printed it out. I'm going to close it. What? Oh. I need to move this. Gotta cut it out again. Gotta tape it again. I forgot how annoying it is to work with acrylic. Alright, we're gonna try aluminum. Aluminum. The problem with aluminum is I need to... Alright, so here's the aluminum plate. We're gonna try it. Thing is, it takes forever to drill into this. Okay, fine. Failure, failure, failure. Every time it's a failure. Okay. Oh, I left the tape inside. I mean, the good thing about aluminum is there's no risk of cracking. Okay. Actually, I wonder if I could just do this. Hold it in place. And just put a dot. And have the ink seep through. Okay, we have the holes. I think I'm gonna do the mounting ones first, because I just want to see this thing get mounted. Okay, wait, where's the jack? Fits in. Pretty good. Okay. did you go? Alright, well, turns out aluminum is a little stiff. So I broke the bit, and I can't find another 1/8 inch bit. Okay, well, in that case, I guess I'm just going to go back to soldering. We could try to cut more acrylic, but it is such a pain. It's such a pain to drill into acrylic. Damn, I really wanted to test that it worked. Alright, fine, let's switch gears. Okay. Fine. Fine. Okay, that was a total fail. We're gonna need to fix that. Alright. So back to a bunch of soldering. Cue soldering montage. Alright. Okay, so the first thing is we got to get our bomb. We got to get the bomb for okay. How do we? There's a shortcut to make this. Hello? Hello? Are you listening? Excel, the program that has literally billions of dollars, is frozen because I. Dude. Hello? This is insane. That sound is the single worst sound ever made by any human ever. Alright, I can't be bothered. We just need to make it. How do I add a new line? Oh my god. There's no way to add a new line? There we go. How do I swap these two? Okay. Okay. 10Ks, 100Ks, transistors. I don't know why the mounting hole shows up in the bomb. I guess it makes sense. Sort of. Okay, let's see what else I got in here. I need to go upstairs and find all the right resistors. What are those? Dude, see, the footprint didn't even print. It's just like, software is so awful. But what was I looking for? I'm looking for these. Wait. Oh, we have the 1Ks. Okay, we just need 20Ks and 82Ks. No. Okay, we got everything. I can take this. Okay. right. Write this down. Okay. So let's just start. We'll do the transistors. So let me just close this. Broom. I hate that sound, dude. Broom. All right. Much better. Full brightness. Okay. So Q1 and Q2 up here. And they're all BC548. Shouldn't like me. I didn't mean to put you under my spell. Yeah, we need some music. Is that a remix? Okay, we can start. What is this, dude? I like this. Yeah. Oh, it's printed double-sided. Lame. Okay, the 100 Ks. We actually want this, but we want it smaller. Bruh, it matches way too much stuff. Okay, R1 and R2. Okay. Wait, can I actually search the values? Search footprint values. Okay, it doesn't really matter which ones we do where. At the same time, fuck, dude, this software sucks. Pin 2. Okay, wait, let's put them all in. Okay, wait, I just want R3. We did R3, right? Okay. We only want the exact value. Wait, no, R5. R5 is the second one there. R13. Okay. R14. Okay. R14. Okay. R15. Okay. Okay, I'm gonna do these now. Okay, so R1. Wait, actually no, let's put more in. R17. So indecisive. So this is right above the connector. Okay. R17, R20. R20, J6. There's 4 resistors and it's at the top. Alright, I have 2 more of these. Um, 21. Okay, it's right there. And then 27. Where you at, 27? Um, okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's a lot. Quarter what? Quarter what? Quarter what? A quarter ounce stink? Uh, bruh. To do this kind of stuff, you really need a drill press. Because like I just destroyed that bit. And I saw that it was flexing under tension. I was just pushing down too hard. But like, if you don't press down hard, you know what I should have done? I probably should have sped it up. It's probably at too low of a speed or something. Okay, nice. So we have up to what did we do? 27? So we just need 2 more. Cool. Venkman. 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 Okay. 30 and 31. Might as well put some more down. We'll put down the 10Ks. We need 6 of those. My beautiful resistors. I love these resistors so much. I love these resistors like an unhealthy amount. 30, 30. We need a 30. There it is. J9. 30. Alright, it's right by the ground. It's the third in this series of 4. I remember I was so done doing the layouting of this board that I was just like, you know what? I'm just going to drop these resistors wherever I want. And then it routed totally fine. And then 31's right above it. Quarter ounce of pink. Okay, so now we want to put in. Well, actually, all right. Let's do them in order. I can't bring myself to not do them in order. So we want the 100 ohm resistors. Oh, let's use that old one. Okay. Brown, black, black, brown. Yep. Okay, so this is R2. R2, where are you? Dude, this is so insane. Dude, the search is so garbage. I don't know how people use this shit. The search is actually shit. R2 just gives you 11 hits, even though there's a like. What do you put if you only want the exact part with that name? Like, you can't put anything. Okay, it's now 19 and 26. Okay. Venkman. Psst, Venkman. And then 26. Okay. Okay, let's put these guys in. Ochre. Oh yeah, we didn't do these. The CNC drill press is such a big ass dream of mine, dude. Something that just goes in there and is like, oh, I need to drill all those holes? No problem, boss. Okay. Okay, so what did we do here? We did. Now we need the 20Ks. And we can put away the 100 ohms. And we need 6 of these. Flip it, we flip it, we flip it. Okay, so R4. 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 Okay, R8. Which is right below ground. R8, R18. R23. R23. Coming from pin 12. We flip it, we flip it, we flip it. Wait, why did I get one extra? R4, oh wait, R9. I didn't do R9. Wait. Wait, R8 to 20K. Oh, this is also, okay. I was like, I definitely got 6. Okay, R25. Alright, yeah, that makes sense. Okay. Yeah, let's just do these. This land is your land. This land is my land. From California to the New York Islands. The Gulf Stream waters. This land was made for you and me. This land is your land. This land is my land. From California to the New York Island. Gulf Stream waters. This land was made for you and me. This land was made for you and me. This land was made for you and me. 20K is done. Now we need the 82K. There's a few enough of these that I will do this. Yes, R6. And put the 20Ks away. We need the 82Ks. So we need these guys. Okay. I don't understand how the amplifier works, I'm not gonna lie. So debugging this is gonna be a nightmare. I sort of understand how the envelope works, but I really don't get how the amplifier works. Honestly, I feel like I should have just used an op amp and then made it a quad. Okay, now let's do. Wait, did we already do the 10Ks? I don't think so. Yeah, with a quad op amp. I don't know how you design it. Okay. 10K. R7. Alright, so let's fold these up. Okay. R7. R11. R10. R28. R24. I love how not symmetrical this thing is. Dude, this thing is just so bad. Actually, should we do maybe a live stream where I go and actually change the KiCad source code? Maybe that'd be cool. This one's tricky. Wow, look at all these pins. Crazy. Hey, I made up my mind all the time. Ah. Ah. I need to remember the pinout for this thing, because oh, that is so satisfying. Makes me come, baby. Makes me fucking come, baby. Not really. Oh, fuck, I'm an idiot. Oh, fuck. The trimmers... Oh, shit, bruh. I can't believe I forgot about that. Alright, what are we gonna do? Um... I do not know what to do. But I can't believe I did that. Come on. I have an idea. If we want this to ever finish, we're gonna sacrifice them. I fucked them up. That's my bad. But they must go. That's a huge shame. Let's see what we can do, though. I mean, they're long enough, but not by much. Okay, we fixed one. We fixed the easier of the two so far. Not the worst, but we got one. Damn, I really messed up the front plate thing today. Not my best work. Come on, get out of there. Come on, get out of there. Come on, go on, get. There we go. Doesn't seem like there's any damage to the traces. Alright, but now we gotta do this carefully. Put this in. Basically, so it just pokes out of there. As little as possible would be great. Okay, I think we got one, which means that we can do the rest. Which we need to do this one, yeah. Nice. We did these trimmers well. Trim pot. Alright, so we did it. That's the build. Now power. Alright, let's just get it done. Alright, I don't want to throw these away because they're totally good. But they're also the ones with short legs. Alright, we're almost done with this chip. This printed circuit board. Almost done. So what do we have in the way of control? I guess we have a volume knob. Yeah, so volume knob, CV signal. We have a lot of control. 1, 2, 3, 4, 5, 6, 7, 8. We have 8. Because we have 6 just for input and then the output. Okay. Makes sense. Ring. Makes sense. Okay. We'll do red, white, black for that. So when you build 2 of those. Random question. If you could choose anyone to see get tickled as a prank, who would it be? I don't know. Yo, who is this, bruh? The tickle guy. Okay. Okay, so let's just do it. What value potentiometers are we supposed to use? That's the problem with these. It's 100K potentiometer. So we need 200K potentiometers. Oh yeah, I wanted to see how long has this stream been going on. We're at 6 hours. It's not bad. All right, so we need 200Ks. Then we need our power connector. So where are the 100Ks? See, this is the problem, is I'm already down to 1 left. Okay, so we have the pots. Oh, and then we just need the wires with the... How many do we have left? We might not even I might need to go scavenge. We need 6 of these. Oh shit, I gotta get the flux. I hate that stuff. Wait, this is 4. Damn, I should order some more of these. I think I know where some are in the basement. Alright, we're not gonna do this. Should I do this? Then it's basically ready for paneling and testing. Okay. I'm gonna wear the freaking respirator, bro. I hate that stuff. Okay, so we gotta cut the wires, and then I gotta find 1 more of these, because we're out. And then I should buy some more, actually. Okay, I forgot what I was gonna do. Okay, so so the pots, we need red. Okay, all right, I get it. Okay, let's just do all this stuff that's not freaking toxic. Okay, and then CV. Oh, so we need actually 8 of these because all of these. Did I put the 1K trimmers or the 100K trimmers? Oh, nice. Okay. Oh, yeah, I was going to order more of those. I think those were kind of expensive, though. I guess they don't sell them. I guess they're out. Okay, I got a different brand because the other ones were going to deliver like February. It's not going to work. Okay, that's nice. So now we need a whole bunch of wire because we need 6 plus. We need 9 of these. We need 9. Damn, this is a painful build because it takes so much wiring. Whoa, we're out? Damn. I'm guessing that we have more wire somewhere. Okay, so these 4. Okay, now the red. We probably have enough red for this. So we also need, no, here we only need 3 of these. Because CV we're making white. Okay, so then we need 6 white. And then we need a blue. Wait, we need more than that. We need cuz no, we need 8 of these. Okay, how many is that? It's 2, 4, 6. 7. 8. Okay. Now we need a blue. Okay. Some of this is so rote, man. Okay. Nice, 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 nice. Maybe we should try making power like really long. I just decided on 10 centimeters because that's what I use for everything else. But it could be useful to make them long. Two. Okay, done. Okay, so now let's just get the pots done. Okay, so let's see the pinout. Pin 1 is red. Damn, it doesn't really hold on to there. Okay, pin 1 is red. Pin 3 is black. And pin 2 is white. Dude, the soldering to these things is infinitely easier than soldering to these jack sockets. Oh, 10 more is not that many. The filter probably takes... Yeah, but there is some downstairs. Like, I'm kind of going overboard. Okay, so this is the same exact thing. This is red. White. Black. Bruh. Okay. All right, so the that's done. Okay. The problem is, all right, so I can only do 4 of these right now. Oh no, I can only do 2 of these right now. I don't know where wire would be. Okay. Fine. All right. Whatever. Maybe that's a wrap. That's a wrap for today. I might do some self-study or something. I think I'm gonna do some... Whatever. Alright. So we need wire, and then... we need, jacks. Alright. Peace, my friends. It's a stream.